Welcome to lesson 4, and I hope that so far you enjoyed the previous lessons and also the videos, and also you learned something from these videos. Alright, so let's look at 3 objectives for the lesson today. We're going to try to review how to solve proportions and try to apply the ideas of cross multiplication, 交叉相乘法, simplification, 约分, 简化, and also algebra 1. Okay, and also just keep in mind that I am actually picking up what's left from lesson 3, and I'm looking at some examples from 2 worksheets from Manage Back. So if you go back to Manage Back, you find out Unit 6, where is the proof? You will find the 2 worksheets I'm speaking about today, solving proportions and also similar polygons. So when you click these 2, you will find the practicing problems here. So I'll be talking about some examples here, and I'll let you finish on your own in your own free time. So don't forget that you want to really go through all of them, and then you can jump in and ask questions during Zoom meetings or my office hours. Okay, all right, so that's the first objective we're going to cover for today. The second one is we're going to use the idea of proportions to state if polygons 多边形 are similar. 多边形是否相似? All right, so again, we'll be taking a look at some examples. And then finally, we'll be talking about some examples of closed system in mathematics. Okay, it was actually a conceptual question left from lesson 2, one of the inquiry questions. I asked you to think about what does it mean by closed system. Okay, so today we'll be looking at some examples. And also, this is an open-ended question, but I want you to think about how is it related to logical thinking. All right, so let's start from solving proportions by looking at the practice question here. So as you can see from here, this is an equation. You have 6 over 2 on the left-hand side and 4 over p on the right-hand side. Okay, so there are 2 ways to solve the problem. The first one is we're going to use cross multiplication. All right, so we'll be looking at 6 multiplied by p equals 4 multiplied by 2. Okay, so that's why I wrote this equation here. And then we're going to solve the equation and then find out the p, the value of p, which can be represented as 4 over 3, or you can write it as decimal, which is 1.3. And then you see the bar over 3 that represent that it's a repeating decimal. 无限循环小数，所以算出来的答案会是 1.333333. Okay, so that's the first way to solve this problem. Let's take a look at another way. Okay, so as you can see here, I actually use a different way to solve the problem, to think about the ratio between the denominator and the numerator here. So as you can see from here, that 6 is 3 times 2. Which is represented here. Okay, so I can imagine, because you see an equal sign here, so the relationship, the ratio between 4 and p would be p times 3 would be 4. That's why I wrote it here. Okay, so you can use the same ratio to solve the p, which you can find the answer will be the same, 4 over 3. Okay, so there are 2 ways of thinking about solving the problem. One is cross multiplication. 2 is to think about the ratio between the denominator and the numerator. Okay, all right. So you might want to go back to the worksheets and try number 1, 2, 3 until number 8. As you can see that all the problems are similar. Okay, all right. So let's continue. Okay, let's take a look at a variation here, in which you will see that, okay, right now I have a variable, but it's not a completely variable. It's not simply one variable in the denominator here. Instead, I see a minus 3. Okay, so how can I solve the problem? Okay, again, you can use 2 different ways, the ratio method or the cross multiplication method. All right, so let's take a look at the ratio method first in the red part. As you can see that the denominator here is 10, and it's equal to 2, the numerator, multiplied by 5. So as you can see that here is an equal sign. So on the right hand side, you will see that a minus 3 would be equal to 4 multiplied by 5 as well. Okay? All right, so that's one way to think about the question. The other way to think about the question is cross multiplication. So as you can see that 2 multiplied by a minus 3 will be equal to 4 multiplied by 10, as stated in the green part. All right, so you can actually solve the equation to find out the one variable, and then you can see that a is equal to 23. Okay, so don't forget that you always want to verify your answer. So the quick way to verify the answer is to replace 23, to substitute 8 with 23, sorry. So you can see that here the denominator will be 20, okay? So 4 multiplied by 5 would be 20. That's how we solve the problem. All right, so again, if you go back to the worksheet, you will see that this is question number 14, and you can solve the similar problems from number 13 until number 24. Use similar method. Okay, so if this is a little bit complicated for you right now, I encourage you to pause here and then take a look and practice a few questions before you move on. If this is a piece of cake for you, let's move on. Okay, so again, let's take a look at another variation of Algebra 1. Right now, you can see that it's kind of different here because in the denominators for both sides, you see b, the variable, plus a constant. So it would be quite difficult for us to figure out the ratio between the numerator and the denominator. Same on this side. So in this scenario, the only way we can solve this problem to find out the value of b is to use cross multiplication, 交叉相乘法. All right, so that's what I'm going to do right now. I'm going to use 6 multiplied by b plus 5 equals 4 multiplied by b plus 9. All right, and you're going to use distributive property, 分配率, to expand the equations on both sides. So on the left-hand side, you have 6b plus 30. On the right-hand side, you have 4b plus 36. And then you're going to minus 4b from both sides. And then you're going to minus 30 from both sides. The other way to think about that is you are going to collect all the like terms together. So you're going to move all the variables, the b variables, to the left-hand side, and all the constant 常数 to the right-hand side. All right, so here you just use simple operation, okay, subtraction, and then you'll figure out that 2b is equal to 6 and b is equal to 3. That is our answer. So as you can see that as a way to find out b here, you're going to use ideas that you learned in Algebra 1, which you picked up in grade 6 and grade 7. Okay, again, you're going to find similar problems here in the worksheets, and I would suggest that you can see that this is the problem that I just worked on. You'll be looking at 24 as a similar example, or 23 as another example. All right, and again, if you're still feeling a little bit confused, pause the video here and then think about that and practice. All right, if this is okay, this is manageable for you, let's move on. Okay, so let's take a look at the second objective for this lesson. We'll be looking at similar polygons. And the worksheet would be this one, when you look at similar polygons here on the top. Okay, and again, I just copy and paste some questions from this worksheet here, okay? So let's take a look at the first one. And before we jump into that, let's think about what similar polygons are. 什么是相似的多边形? Okay, so similar polygons means that the proportion between the length should be the same as the one between the width. Okay, 也就是说，两个多边形，比方说两个长方形的长的比会跟宽的比是相同的。Alright, so let's use this idea, this concept to solve the first problem. Again, we have two ways to think about if these two polygons are similar. Okay, so let's take a look at the first one. Okay, so for the first one, I am actually identifying the length, which is 14 here, and then 21 here, and then the width would be 10 and 15 here. So I am comparing, okay, I'm comparing the ratios of the length and the width first. So the ratio between the width would be 10 to 15, which can be simplified as 2 to 3. The ratio between the length would be 14 to 21, which can be simplified as 2 to 3. So as you can see that the two ratios are the same. So we can also tell that all the angles are right angles. So they are rectangles and they are similar rectangles. So it's proved here. Or the other way to think about that is we're going to look at the ratio between the length and the width in one rectangle and then compare the ratio to the ratio in another rectangle. So 10 to 14, which can be simplified as 5 to 7, that's the top one. And the bottom one would be 15 to 21, which can be simplified as 5 to 7 as well. So as you can see that the ratios are the same, so we can confidently state that yes, they are similar polygons, they are similar rectangles. All right, so if you figure out the concept here, I would invite you to try to solve the following problems here. As you can see that some of them, they are a little bit complicated, but give it a try. Okay, and again, welcome to pause the video and digest a bit or practice a little bit on your own. Otherwise, we're going to move on to another example. All right, let's take a look at this example here. Here we see two parallelograms, 平行四边形. Okay, so what is a parallelogram? Here you see the definition. A parallelogram is a flat shape with opposite sides parallel and equal in length. So a flat shape means that it's 2D, it's not three-dimensional. Okay, 平面的. All right, and then you can see that the symbols here, the congruent symbols here shows you that these two sides, they are with the same length, okay? And they are parallel to one another. And then these two sides, they are parallel and equal in length, all right? Okay, and then you can see that angle A is equal to angle A, angle B is equal to angle B. And also, okay, we'll find another time to prove why angle A plus angle B is 180. But right now, you can just keep in mind that in a parallelogram, you have two pairs of equal angles. And the two pairs, when you add them up together, you will get 360, okay, 360. And then if you just add one of them together, A plus B, that will be 180. All right. So we're going to use this important feature to look at if these two parallelograms are similar. So as you can see from here, let's start from the bottom. You will see that the width of this one is 5. The length of this parallelogram is 7. So 5 to 7 is actually equal to 15 to 21. So the sides are proportional. 它的边是等比的，是对比的, all right? But if you look at the angles, you will see that I call this one as angle A. Angle A is 40. Angle B here, the obtuse angle here, 钝角, this one would be 140. But if you take a look at the second parallelogram, you will see that the obtuse angle here would be 130, and the acute angle, 锐角, it would be 50 only. So as you can see that, well, the angles are not the same. So that's why I wrote it here. The corresponding angles are not congruent. So that shows that these two parallelograms are not similar. In other words, if we want to prove that similar polygons are similar, you want to show that first of all the angles would be the same, or all the angles would be congruent, okay, under different circumstances. And then you look at if the sides are proportional. All right, so again, you might want to pause the video and then try to solve the problem. Okay, so if this is clear, let's move on to next part of the lesson. All right, here is a critical thinking question for you. So since we've learned about proportions and also similar polygons here, I want you to think about this question which you might see in daily life. Do you think that a person's age and the amount they eat every day are basically in proportion? In other words, if I am 10 years old and you are 20 years old, are you going to eat double or twice amount of the food that I eat every day? All right, pause the video, think about that, and write down your reasoning. Why or why not? Okay, so let's move on. All right, so let's move on to the third objective. We're going to think about what closure or what a closed system is. All right, okay, so let's take a look at the diagram on the top. So a closure, mathematically, is when an operation such as adding members of set such as real numbers always makes a member of the same set. In other words, take a look at the right one. You will see that this is set. Okay, an operation can be addition, subtraction, multiplication, and division, 加减乘除. You will see that all the members, all the elements, they would be in the same set. We call this as a closed set or a closed system. Whereas on the right-hand side, you will see that, well, this yellow one is outside the set, so it's not a closed system. So what does that mean? It's so abstract. Let's take a look at some examples. So for example, when we add two real numbers, 实数, okay, try to pick up the concept. Okay, we learned about that in Unit 4, number sets. Okay, when we add two real numbers, we get another real number. Okay, so all the operations would happen within the number set of real numbers. So for example, if you add 3.1 to 0.5, you will get 3.6. And 3.6 is still a real number. Okay, so we know that real numbers are closed under addition. All right, let's take a look at another example. So if we conduct subtraction and we focus on whole numbers, okay, so let's take a look at this one. So if we use 4 subtract 9, we will get the answer as minus 5. And as you can see that minus 5 is not a whole number, okay? So because we know that whole numbers cannot be negative, it needs to be bigger than 0. So we can prove that whole numbers are not a closed system under subtraction. So it would be this one. All right, so this is one example of closed system in math. Let's move on. How about in daily life? Let's take a look at this extension of logical thinking. So, for the operation of wash, the shirt is still a shirt after washing. So shirts are closed under the operation of wash. In other words, a shirt is always a shirt. The condition, the features, the textile, the texture wouldn't be changed. But for the operation of rip, a small rip may be okay, but a shirt ripped in half ceases to be a shirt. So shirts are not closed under the operation rip. Okay, so right now let's stop the video and then try to think about if there are any closed systems in your math learning. There are some hints for you. Try to think about number sets, definitions of different triangles, linear and quadratic equations. And also, can you find out some systems that are not closed systems or closed set? Okay, all right. So we'll come back to this idea of closed system later because it's really helpful when we continue our learning for mathematical proving and also logical thinking. Thank you for watching this video. Don't forget to go back to Manage Back and then find out solving proportions and similar polygons to practice. I'll see you next time. Bye-bye.